Claude Code changes AI engineering by working inside the repository. It can read files, run commands, and edit code directly. It iterates through problems with developer oversight. The real value isn't faster autocomplete, it's a new workflow layer for AI engineering. Repo understanding becomes part of the loop. Refactoring, testing, debugging, and review are now agentic. These tasks form continuous engineering cycles. Most coding assistants struggle with real engineering tasks. They fail when facing unfamiliar codebases. Hidden conventions are hard to detect. Brittle tests often break unexpectedly. Old decisions linger without clear reasoning. Documentation is scattered and incomplete. A chat window can't grasp architecture from one file. Production engineering needs deeper insight. The assistant must inspect the entire project. It should follow dependencies across files. It must run verification checks and connect changes to actual repository behavior. Code is judged by builds, tests, and runtime behavior. Linters and security constraints also play a key role. Review standards shape how code is evaluated. Without feedback, AI coding becomes confident guessing. Claude Code closes the loop effectively. It inspects code, makes changes, and runs checks. It reads results and revises based on evidence. Improvement happens through repeated cycles of feedback. Claude Code is more than just a code generator. It operates as an agentic coding environment. The workflow follows explore, plan, implement, verify, and repair. Engineers describe the desired outcome instead of isolated snippets. Claude examines the repository for context. It proposes a clear path forward. It edits files directly within the project. It runs necessary commands automatically. It shows its reasoning step by step. This allows humans to review and correct the process. A strong workflow starts with clear repository instructions. CLAUDE.md captures architecture rules and coding conventions. It includes test commands, deployment notes, and forbidden patterns. Review expectations are also documented in CLAUDE.md. This transforms tribal knowledge into lasting team memory. Claude no longer begins each session without context. It inherits the team's engineering standards up front. Before touching code, Claude already knows the rules. Refactoring starts with discovery, not editing. Claude Code maps all files in the repository. It identifies dependencies between components. It locates duplicated logic across the codebase. It reads existing tests to understand behavior. It explains the intended change before any modification. This protects the overall architecture from shallow changes. The goal isn't fast rewriting. It's making the smallest safe change with full context and understanding. Testing gives Claude Code a clear finish line. Unit tests, integration tests, and build commands become objective signals of success. Lint rules, type checks, and fixtures also serve as measurable criteria. When Claude runs these checks, failure turns into useful input. No longer just the patch looks right. Now it's the patch survived verification. Debugging reveals the agent loop in action. Claude reads the error message carefully. It traces the call path step by step. Then it forms a hypothesis about the cause. The agent changes just one layer at a time. It runs the failing command again. It revises its approach based on the result. This method targets the root cause directly. It avoids just masking symptoms. The best prompt gives Claude the failure. It demands proof that the fix works. Claude Code supports pull request reviews. It analyzes code changes in context. It flags logic errors and edge cases. It identifies security risks and regressions. The goal isn't to replace human reviewers. It's about catching issues early. Review becomes a layered process. First, automated inspection, then human judgment. Finally, the merge decision. Engineering agents need clear boundaries. Claude Code workflows must define allowed commands. Protected files should be explicitly listed. Approval gates must be set for critical actions. Secrets handling requires strict controls. Network access needs proper restrictions. Safe execution modes are essential. Autonomy without permission is risky. Production teams decide what Claude can read. They determine what Claude may edit. They control what Claude can run. And they set when it must stop. Claude Code grows more valuable in team workflows. GitHub Actions can answer issue questions. It reviews pull requests automatically. It implements focused fixes efficiently. It generates structured outputs consistently. It runs on your own infrastructure. The architecture shifts from one developer to an engineering system using AI at workflow boundaries. For CCA candidates, Claude Code teaches governed autonomy. The winning pattern is not letting AI code everything. It's about context, instruction, permission, and verification. Include review and traceability in every step. Use Claude Code to speed up engineering loops. Keep humans in charge of architecture and security. Humans make product judgment and final merge decisions.